Good afternoon, everyone. It's a session after lunch, so if somebody wants to meditate also, it's fine. Okay, so so we know that IoT has revolutionized the way we live and work. From smartphones to industrial automations, IoT has enabling IoT has led us in enabling innovation and productivity in our daily life. But the technology of IoT seems to be a little complex because we need to have expertise in software, hardware, as well as cloud computing. So that is where this AWS IoT and Raspberry Pi comes into picture. So AWS IoT is a managed service which allows you to connect, monitor, and control IoT devices. On the other hand, Raspberry Pi is a versatile, very low-cost single-board PC. Its dimension is just around 85 into 55 millimeter. So this will let you create IoT devices at ease. So today, my intention is to give you some basic idea on how we can integrate this AWS IoT core and Raspberry Pi. So we will have start with some basic discussion, and then we will move on to the integration part. So without much delay, let's go to the agenda of the topic. So we will have an introduction of what IoT is, and also we will have introduction of Raspberry Pi and some devices which are used to connect to IoT. Then we will talk about AWS IoT thing, which is the core part of AWS IoT. And we will talk about, once we get into cloud, how the storage is being done, and how, after storage, how we can compute the data using Lambda and EventBridge. Also, we have visualization tools like Grafana for seeing the visual structure of the data. And in the end, we will see the overall architecture of the demo. And I will show you a small video demo where all these pieces are integrated. So IoT, by definition, it says it refers to a network of interconnected devices that will collect, exchange, and process data to perform specific tasks. So it is a collection of multiple devices that will connect each other, sense data, and process the data to get some output. So let's have a discussion on the core components. So core components, first is a devices or sensors. So these devices or sensors we can term as the eyes and ears of an IoT devices. So these devices collect data from the external environment and send it to other components for processing. For example, we can consider in terms of environment sensors. We can have temperature sensor, we can have pressure sensor, and capture the data. And for motion sensors, we have accelerometers, we have gyroscopes, which collects the motion details of vehicles and all. And also even we have camera and microphone, which can capture the audio and the visual details as data. So these are the devices part. And when we come to connectivity, that we can consider as the backbone of an IoT system. So connectivity will collect the data. Once the data is collected to the device, this connectivity will ensure that the data is passed to other devices or to cloud for further processing. So we can use connectivity, like we can use a Wi-Fi network for connectivity, or a 2G, 3G, 4G connections also can be used. Or also we have low power connectivity networks called a LoRaWAN and all. Those types of connectivities also can be used. So these all components constitute the connectivity part. So once the connectivity is done, we have the data processing. That we can consider as the brain of IoT system. So this is where we convert this data into actionable insights. For example, if you collect the temperature of a room, it will, based on the data processing, It will decide whether we need to increase or decrease the temperature of the room. And also there are two types of data processing. One is edge computing, whether the data will be processed within the device itself or in the edge of the network. That is, in the network, edge of the network, there will be some process to process the data. Or we take the whole data in the cloud, and in the cloud, the whole processing will take place. And after that, we have the user interface. User interface, nothing. It's like the eyes of. It is like the face of the IoT system. So it can be a mobile app which will give you alerts based on some data insights, or it can be a web application where you can see a visualization of the product, or a simple voice assist like Google Assist or Alexa services. So these are the core components of IoT. Then coming to the examples of IoT, we have numerous examples of IoT. So we are all wearing smartwatches. So smartwatches can collect our heart rate and give us insights about that. Or it can collect the number of steps we traveled in a day, and it can give how much calories has been burned. And it can also use for smart homes where you have thermostats which collect the temperature details of a room and give valuable insights. In terms of industrial automation or smart cities, IoT has revolutionized the way the smart cities projects are taken care. For example, in terms of traffic control, IoT can regulate the traffic control and manage the traffic congestion in an area. Or in terms of waste management system, IoT can understand the waste collection routes, and it can reroute the waste management system based on the data. So there are numerous examples of that. So when we come to healthcare management, IoT can have remote patient assistance system where the medical details of the patient can be tracked and sent us to medical officers for further examination. So there are numerous examples in various fields of IoT when we take that into picture. So coming to Raspberry Pi. So Raspberry Pi, I told like it is a low-cost, versatile, single-board PC. It was initially developed by Raspberry.com Foundation in association with the Broadcom, and it is powered by just a 5-volt micro USB power supply, and it has a Linux operating system. So we can run Python codes inside Raspberry Pi as we can run in any other system. So Raspberry Pi, we can use it as a web server, or as a gaming console, or even as a home automation system. So we can have various types of application which can be done using Raspberry Pi. One of the interesting facts of Raspberry Pi is it has this 40 pins on the right side, on the right corner of that device. So these pins are its interfaces to the external world. That is, through these pins, we can connect this sensor to the Raspberry Pi. For example, if we have a temperature sensor, we can connect the temperature sensor to the Raspberry Pi through these pins, and that is how we collect the temperature details or the humidity details. So if you see Raspberry Pi, it has a 5-volt port, it is a 3-volt port, the ground pin is there, the data pin is there. So if we can connect to the corresponding pins and get the data from that. So these are some samples. So DHT11 temperature humidity sensor is a sensor which can detect temperature and humidity. So this is how we connect Raspberry Pi to the DHT11 sensor. So it has basically 3 pins, and one is a voltage pin, and other is a ground, and other is a data pin. So if we connect this to IoT and run Python code, we can collect the room temperature and humidity from the sensor. And similarly, we have this is a IC2 LCD screen. So it has also 4 pins, and it can be connected to IoT, connected to the Raspberry Pi, similar to how we connect the sensor machines. So this also using samples Python code, we can display any messages to the LCD screen. So these are some devices we connect to the Raspberry Pi, and how we integrate with the devices. So before moving further, we have to talk about MQTT. So MQTT is a lightweight message protocol from sending data from Raspberry Pi to cloud. So it is specially designed for sending data where we have low bandwidth and low power availability. So when we send data from the device, the Raspberry Pi, to the cloud, we use this MQTT protocol. And AWS IoT support MQTT protocol. And one of the features of MQTT is called a quality of service, where it ensures that the data which is sent from the device to the cloud is reliable. The data is not lost, even if there is a failure in network. Okay, till now we are talking about the components and all. Now we will discuss like how we will create the AWS IoT thing in the AWS console and how we will integrate it. So to start in the AWS, what we need to do is we need to first create an IoT thing. So IoT thing is nothing. It is a logical representation of a device. For example, if I am connecting a Raspberry Pi to an IoT, then my Pi machine is an IoT device. Or it can consider as a light bulb. A light bulb can be an IoT device. So I will create a thing named light bulb. And another thing is the thing type. So thing type is a collection of things. For example, if we have n number of light bulbs and we want to connect data from all the light bulbs, we will create a thing type called a light bulb and add attributes to that. For example, the serial number, the wattage value. So all these attributes will be set to the thing type, and the thing will be attached to the thing type. So thing type is just a collection of IoT devices. So first step in AWS is create a thing and define the thing type. Okay, so as I said, the thing is a logical representation. So if my Pi is the device, then in my AWS console, I will create a logical entity for the Pi. Now, so once I create the thing and thing type, once it is created, so I'll be getting these files as an output. The thing is created. Also, I will be getting a private key, a public key, a device certificate, and root CA certificate. So these certificate files, so these are the files which ensure the authentication of the devices. That is, these files I will import to the Pi machine. And when Pi tries to connect with the IoT, it will use these certificates for authentication. So AWS IoT will create certificates based on the root CA certificate. So to create any certificate, we need it to be signed by a certificate authority. And AWS has its own certificate authority, Amazon root certificate authority. So the certificate will be signed by Amazon root CA authority. And these certificates, as I said, it will be imported to the device. And when the device tries to communicate with the cloud, these certificates will be referred. So when a device tries to connect to IoT, the AWS IoT core will request for the X509 certificate of the device, and it will validate the certificate and the AWS account against a list of certificates. So, and once that is validated, it will again challenge for the private key of that device private key from the certificate details. So it is very similar to how we make an HTTPS request to a server. The authentication happens in a very similar fashion. Here the authentication is happening. So through these certificates, the authentication will be established. So once the authentication is established, are we ready to send messages and IoT send write and read messages. So only the authentication is established now. We have one more part along with authentication. Any guesses on that? We need to have the authorization also to set up. So the authentication will just establishes a connection between the Raspberry Pi as well as the cloud. But to write or read messages, we need to create policies. So policies are, we will say this, AWS IoT core policies. So those are very similar, very exactly similar to the IAM policies, where we will define what kind of permissions we are giving to the device. Whether it is just to connect or to write messages or to read messages. So those details will be told in the policy. So the policy will basically authorize the system to read and write messages. So it will basically give control to the AWS IoT core data plane, which has the operation which lets you connect and read and write messages to the IoT. So in short, if we do the authentication through certificates and authorization through the policy, your connection will be established and you can read and write messages to the IoT. Further short, if you have a data in your Raspberry Pi, by setting these things, these certificates and the policy, you can send the data from the Raspberry Pi to the AWS IoT core. So basically data will come to cloud, setting this. Yeah, once the data is available in the cloud, we need to process it, right? So before processing the data, we need some kind of a storage. So by the rise of IoT systems, there is a new type of data came into picture. That is called a time series data. So that will measure how things change over a time. It is not like a conventional SQL data. So we need data over a range. And from that range, we need to take some actions. So that is the type of data we are getting. So conventional SQL databases are not capable of processing this data because of the expectance of action we need to take in a faster phase. So those kind of databases are incapable of processing that. So that is where the time series database came into picture. So it is a serverless purpose-built database where we can process trillions of data within milliseconds, and that too at 1/10th cost of conventional database. And AWS supports time stream database, and that service is called a AWS time stream. And also one of the advantages, it is capable of managing the life cycle. That is, if we get some data from IoT, we take some action. After that, we even may not need the data. So we can send the data to other low-cost storage systems, or even we can discard the data. So this lifecycle management is inbuilt setup in the time series database. So we will use the time series for storage. These are some key concepts of AWS time stream database. So time series, as I told, it is a series of one or more data points. So it is a collection of data over a period of time. For example, we can say the temperature, humidity value captured over a period of time, or the stock price over a period of time. Or a record is a single data in the time series. And the dimension we say as an attribute of the time of the metadata. Dimension is nothing but it can be the filter of the data. For example, we store data of a device and we say the device ID as a property, then device ID is a dimension. And next is a measure. Measure is the actual data what we are capturing. For example, in case of temperature and humidity evaluation, the temperature values and the humidity values are the actual measures we are capturing. Timestamp is nothing, the time at which we capture the data, it will be automatically captured. And table and database it almost falls in line with the concept of table and data in sequential databases. Okay. Okay, so now we talked about the storage part. But how will we have to connect it, right? We have the data came in the IoT, how we will transfer it to the storage. For that, we have message routing rules available in the IoT. So in the message routing rule, we can say from the IoT core, send the data to the time stream database. So IoT core, the messages, as I told about MQTT, so IoT comes through MQTT protocol, message will be delivered as a JSON. So this message we can transfer to the storage, that is AWS time stream, using message routing rule. So in the routing rule, how we can transfer? We can write SQL-like statement like select temperature, humidity from the topic. That name we are seeing IoT/DHT sense. That is the topic, and from the topic we will send to the table, the time series table. So this is how the data is transferred from IoT to the storage. Yeah, once we store data, we are clear how to process it. So we can configure an event bridge and a Lambda to process it. So event bridge scheduler we can schedule to run at specific intervals. For example, every 1 minute, trigger the event bridge. Event bridge will trigger the Lambda. And Lambda, what it does is, it will poll the time series database, and it will get the data. And it will do the process whatever it wants. For example, if we want to compare the temperature, pressure, and if it is above a threshold, we might have to send the data back to the IoT. So Lambda, what it does is, if the temperature is above a threshold, it will send a message back to IoT core. So it will publish another message to IoT core, and this topic, the AWS, this topic, the Raspberry Pi will have subscribed to. So once we send a message from Lambda to IoT core topic, the Raspberry Pi, which have already subscribed to that message, will get the message. So we have completed a full cycle, right? From the Raspberry Pi, we send the data to cloud, then we have stored it, we have processed the data, analyzed it, and based on the feedback, we have sent the data back to IoT core, and then back to the Raspberry Pi. Yeah, along with that, we can use real-time visualization. So this data is in the time series, as I told. So we can have visualization tools. For example, we can have we can install Grafana. So Grafana, we have AWS managed Grafana service, or we can install Grafana in an EC2 instance and set it up. And we can give the source as the time series table. So from the time series, we will get real-time analytics of how the data is behaving. That is how the visualization part is happening. Yeah, so this is the overall of what I told till now. So just to recap, so starting from the Raspberry Pi on the left-hand side, we are connecting the sensors. That is, we are connecting the LCD sensor, and we are connecting the connecting the temperature humidity sensor. So we will collect the data. The Raspberry Pi will collect the data using Python code. And once we get the data is sent to AWS IoT core. How the data is being sent? Because we have the authentication set through certificates, and the authorization done through policies. So through this, the connection is established, and data is sent as MQTT topic. That is, MQTT topic as JSON messages. So data reaches IoT cloud, and there we have configured a message routing rule, using which we can transfer the data from the IoT core to the time stream database. So time stream database, we have configured an event bridge as an event bridge scheduler, which will trigger the Lambda every 1 minute. So the Lambda will poll the time stream, pick the data, and it will analyze the data, whether it is crossing a threshold. And if it's crossing the threshold, it will send the data back to the IoT core as again a MQTT topic. So the Raspberry Pi has already subscribed to the topic. So once the message reaches the IoT core, Raspberry Pi will get the message. So once it gets the message, it can take any actions. Simply, it can write the message to the console like your temperature has crossed the threshold, or it can show the message to an LCD monitor saying that the temperature has crossed the threshold. Okay. Yeah. I will show a quick demo of what we told now. So on the right hand side, what you see is the Raspberry Pi folder structure. So we have the Python code there. I'm not going through the code. So we have a Python code, and along with that, if you see, we have the certificates, what I told. So we create the certificate while creating the thing. We get the private certificate. We get the root CA certificate, the device certificate, and the private key. So these things we will import to the Raspberry Pi in the same folder. And once we go through, you will see that these certificates are referred in the code, and we will connect through these certificates. So I will just run this. Yeah. Sorry. Going to in detail of the code, but these lines I just want to show. So here, this is how we are referring to the certificates, and below we can see the publisher topic and subscriber topic. Publisher topic, as I said, this is the topic where the Raspberry Pi will send the message to, and subscriber topic is a topic is where Lambda will send the message, and IoT has subscribed to this topic. Yeah, and this is how the MQTT client is connecting, referring the certificates. When we run the code, it will capture the temperature and humidity from the sensor, and it will display like 31 degrees and humidity 67. So once the code is run, this is the MQTT topic. So this is the IoT core where the data is being received. And once the data is received, we have created the rule. We have created the rule to transfer the data from IoT core to timestream database. And in timestream, we can query similar to SQL database. So here we are querying the last 1 minute data. And we will get the last 1 minute data. We have the device ID as an attribute, and humidity and temperature as the actual values which are being measured. And also we have the timestamp available. So once this data is available, we have created an event bridge which will invoke the Lambda. Lambda is again a Python code. I'm not going to show the code. So there we will poll the time series database, capture the temperature and humidity values, and if it is above a threshold, we will send it back to the IoT. So here the temperature is already set as less value, that is 28. Initially it was 31, so now itself the data will be sent back to IoT and then to Raspberry Pi. So we can see in the subscriber topic, so the Lambda will process the data, and in the subscriber topic, so we have these are the two topics. The first one is the subscriber topic, and the second one is the publisher topic. So initially we saw the subscriber topic message. Now we are checking the subscriber topic, that is DHT threshold receiver. So here the temperature threshold has crossed. So the message will be displayed here. And since the Raspberry Pi has already subscribed to this topic, Raspberry Pi, the message will be received at the Raspberry Pi. This is the code where we subscribe to the topic. Yeah, and we can see that star lines where we are, as of now, we are showing the message in a console. We can configure an LCD screen to display the message also, or we can take any other action accordingly. Okay. Yeah, I think that's it from my side. I hope you have enjoyed the session. So thanks everyone for listening to me. Just a few takeaways. Nothing much. It's all we told. Like, see, using AWS IoT Core and Raspberry Pi, we can integrate and create projects with ease, because AWS IoT Core, everything is already integrated, so we don't have to do much hard work on that. So whether you are a professional or a student, you can. I think this session have give you some insights on Kickstarted with IoT development. Thank you. Thanks everyone.
Thanks, Kiran. Thanks so much for this session. But if you guys have any questions, please ask. Okay.
Sir, so MQTT is a publish subscribe
Yes.
per protocol, right? So is it only because that you have the transport layer protocol? Because MQTT supports that. It's not a wireless. It's not. Does the IoT core support UDP? In any case.
So IoT Core support MQTT as well as HTTPS.
HTTP, but not UDP protocol.
No, it won't support UDP protocol.
Okay.
Yeah.
Because in most of the wireless communication
Yes.
devices or communication things, UDP is or CoAP is being used
Yes.
as a communication protocol.
Yes.
What would be the reason why this IoT core is not supporting CoAP or UDP?
I'm not pretty sure about that, but I believe the MQTT protocol is the ideal use case for IoT devices, whether we have low bandwidth and even the network is less. So that is a use case.
Yeah, no, even CoAP is also mainly developed for that, especially for the wireless sensor networks.
Yeah.
So here the only issue I see is that you cannot transport anything without an internet connection. That is like you need a transport layer protocol for the MQTT to work.
Yes.
So only with a Raspberry Pi, without a Raspberry Pi as an intermediary,
Yeah.
I don't think then IoT won't be able to communicate.
Yeah, I am not pretty sure, but one thing I know is MQTT support this called quality of service.
Yeah,
Whether-
Q1, Q2,
yeah.
Q3. Yeah,
In
that's-
case of network failure also, it will ensure the data is delivered even if there is a network failure. So I think using that, we will be able to communicate even if there is a slight network failure.
Okay.
Yeah.
So it doesn't have support for co-op.
No, no.
Okay. Thank you.
The backend is using UDP, right? It will use UDP packets in the backend, and just like HTTP use TCP in the backend, it is
Yeah.
actually MQTT also use UDP in the backend.
Here the authentications happens with TLS. The TLS layer only it is happening.
Okay.
Yeah.
All right, any other questions?
Actually, I don't know more about in the Raspberry Pi anything. I just Google search and I can get many board like in. And how can I do in the testing purpose, and what is the procedure for buying this board through connect within the AWS?
See, Raspberry Pi we can buy online, and you can create an AWS account, right? Free AWS account, and in that AWS account you can, as I said, in the IoT core, you can go to the IoT core, create the certificates, and just export the certificates to the Raspberry Pi. And once the policies are set, you can seamlessly integrate with both the services. I think it is less than 5,000. I think even much less than. I am not sure. 3 years before I bought, it was around 3,000 something. Yeah. Thank you.
Thank you. Any other last question? Okay. Okay. Let me ask.
So what's the comparison between Node MCU and Raspberry Pi?
Sorry.
Node MCU modules. We can use Node MCU modules also, right?
Yeah.
ESP. So what's the which actually I was saying that you said around 3K for Raspberry Pi. Node MCU modules very much lesser than Raspberry Pi. So in production, if I have a product which is IoT, so when I go to production,
I have not actually used this Node MCU module, but maybe it is a variety of applicability Raspberry Pi is giving. With respect to the GPIO pins, we can connect to multiple devices, and also it can be used as a web server or a gaming console. I think because of the variety of use cases we are using, maybe because of that, Raspberry Pi is a little costlier than that.
When we go for a product, building an IoT product and giving to the consumer, like Wi-Fi light bulb, so is it viable to use Raspberry Pi or any other modules is available?
It will be based on the use case. Like based on the use case, if the Node MCU module is capable of doing that, only that requirement is required by the Node MCU module and is capable to do that, we can of course go for Node MCU module. Yeah.
Thank you.
How to handle data loss kind of scenarios? Is there any such things when we transfer from the Raspberry Pi to the IoT core? Because in transit, if there is some data that has not been received at the shore, or
Yeah. See, IoT, the AWS IoT, this is the basics of AWS IoT integration and Raspberry Pi. We have other services which process the data at the edge. That is, data doesn't have to go outside the IoT machine. We have AWS Greengrass, which sits as a AWS service within the device itself. So data will not go outside, and data will be processed more real time. So using those services and all, we can ensure that data loss is reduced to its minimum.